Okay, hello everyone. My name is Peyman Momeni. I am one of the co-founders of Fairblog. And actually, I've done my graduate school in Waterloo cryptography lab, and same for my co-founder and a couple of our team members. So it means a lot for us to be here. And so while you are still in your 40-second attention span, I just want to summarize the key points that I really want to make. So probably you've already heard of like private transfers, like Tornado Cash, Zcash, Penumbra, like Aztec, and like ZK rollups, and they are great. But like today, I'm trying to talk more about like other applications of privacy and talk about like how privacy can actually like enable more applications for users, how it can actually save you money, and tell about the fact that it doesn't necessarily mean like bad UX or like trouble with IRS or CIA. And also like the key point up here is like pre-execution privacy and threshold identity-based encryption that we are building. So what's pre-execution privacy first? So right now, all of the applications that we have, like decentralized applications that we have like the messages are public. So if you are sending a message, a vote for a DAO, or like if you are trading, everyone can see your transaction, the contents of your transaction before finalization and the inclusion of your transaction inside the block. So this is the heart of the problem for like MEV, France running, and other stuff that is happening in DeFi. And also it has limited couple of like cool applications that we know for like on-chain applications like Sealbit auctions or like private governance that a lot of people are talking about these days. So the idea is that right now we don't have any privacy before execution. The idea is that we want to protect transactions, the contents of the messages up to the point of execution. After that, everything should be like transparent. It's just for like protecting you from like exploits and also enabling applications. The basic idea is that we can encrypt the transaction contents in the user side, in the front end. And then once the inclusion and ordering and like sequencing of the transactions are finalized, a threshold committee of like, it can be like validators of the blockchain or like DAO members, they can send their private key shares, and a single private key can be generated, which can decrypt all of the transactions, and we can execute it right after that. So this means that all of the transactions will be encrypted, all of the contents will be protected, and nobody has access in any way to the contents of your transaction before execution. So you can rest for this part because it's a little theoretical, but the idea that we are implementing is like identity-based encryption. The classic idea is that right now, like in, probably you know about like private keys and public keys. Using like classic public key cryptography, you should know the public key of the receiver party, right? Like you know like the public key is like some random address, and then you encrypt your message for that specific public key. So the original idea of identity-based encryption is that you can just, without the knowledge of the receiver party, like any information about the receiver party, you can just encrypt some message for like their email address, their IPs, or their photos. And the receiver party, right after that, they can go talk to a like centralized private key generator, authenticate themselves, and they get the private key. So this is called like extraction. And then once you have as the receiver party, you have extracted your own private key, you can decrypt it. So there is like the setup algorithm, which after the setup algorithm, we have the master secret key, which is going to be used by the centralized private key generator to generate a single private key for all of the receiver parties. And there is a master public key for the whole system. So you can encrypt transactions with the combination of the master public key and an ID for anyone. So using the master public key, which is fixed, and ID, that can be your photo, your IP, or like your email address, we can encrypt transactions for the receiver parties. And then the guy can ask the third party to extract the private key for themselves. And it can decrypt using that. So this is the classic idea of IB. How we are using that? We are combining IB with like ideas in multi-party computation using DKG and other technologies like ZK. We have made it decentralized. So the centralized party that I was talking about for extraction of the private key, right now using DKG is decentralized. So instead of asking one person to generate the private keys, a committee of validators can send their private key shares, and this is decentralized. So it can be all of the validators of the blockchain. And the ID, which was email address or IP, this is the condition of decryption. Here, the ID is block number, or just simply the deadline for decryption. So you can encrypt a transaction for a specific deadline. You can encrypt it and say it should be decrypted in block 100. And so we can have the idea of time block encryption using IB and DKG. So right now, I'm going to briefly discuss a couple of the applications that we've enabled using IB and DKG. So the celebrity here is MEV, the bad part of MEV, not the good MEV and arbitrage opportunities, the toxic MEV and front-running attacks that a lot of people have already heard of. The heart of problem is that when you send your trades on Uniswap or something, other people can see your trades. They can put a buy order before your transaction, and then right after execution of the original transaction, they can sell it. So they can make some money because of your transaction, because of having some kind of insider knowledge about contents of your transaction. And this is also called sandwiching. You may heard of this kind of stuff. This is a really big market. It's 1 billion market. Some part of it is coming out of normal retail users' pockets and protocols. And it's been known that this is not good for UX. You should know about a lot of slippage amounts, and it may cause a lot of other complexities. So one of the problems to mitigate consequences of MEV and front running is by having pre-execution privacy, which can be built with IB and MPC, as I discussed. And the other idea that we've implemented is private governance and DAOs. So the basic idea is that we can encrypt your votes, right? And your votes will be encrypted up to the point of the deadline for the voting. Nobody can see other people's vote, but everything will be transparent after the deadline. And once your votes are encrypted, we can send them to the blockchain on a smart contract in Ethereum or in Cosmos. And once everything is finalized, the deadline of voting, the gathering votes is finalized, and nobody can vote anymore, all of the validators, all of the DAO members can send their private key shares, and a threshold of them can be aggregated automatically to decrypt them and tally the results, and the results will be transparent. So why this is important is it can help with information symmetry, less bias and less censorship, shorter voting periods, and it may be helpful for mitigating a lot of social media dramas for governance proposals, to make it more easy to understand and without all of these buzzwords. There are a couple examples here. So most of the time people don't do their homework and their research in governance proposal. They just copy other influential faces, votes, and this is good. There is also off-chain communication, but at least on on-chain communication, you can't just see what's the other people's decision. You should do your own research and then vote after that. So the results will be slightly less influenced. The second point is that if you see that the voting result is already done, and I don't know, if either you are on the winning side, so you don't think that it's important to vote, or you are in the losing side, so you think that your vote is not going to be counted, right? So for the winning scenario, if you don't vote, you may win the election by just 1%, but the reality may be 67%, right? And in the losing side, maybe you end up losing by 0.5%. So if you have voted, maybe the election was in the other side, the election result was in the other side. So this is exactly I don't know, political elections in reality. Nobody can see your votes. Everything is I don't know, in the pockets. So we are basically making the pockets so other people cannot see your votes. And the I don't know, Turkish election or other stuff, there there's like common strategy in I don't know, crypto that major stakers and whales, they wait until the very last second for voting because they can influence the results if they vote, and they wait, and then they just, sometimes it's possible to borrow some stake from other people and then just vote to like just turn the results in the other way. So using like pre-execution privacy and cryptography, we can like prevent this kind of scenarios. The other application that we are excited about is like seal bid auctions. And yeah, theoretically, there is a lot of like, I don't know, research and like mechanism design research that talk about like seal bid auctions. You may know it of like, heard of it as like second price auctions, victory auctions. So basically, second price auctions is better for users because there is like financial incentive for all of the bidders to send their like bids for their real value of the asset. And yeah, there is a couple of implementations in the crypto space, for example, by A16Z, but they are using some kind of like just simple hashing. The problem is that if you want to hash your like bid, you should reveal it yourself. So there is like two interactions. But right now, like with our implementation, since there's a like threshold network of like decryption, you just encrypt it, send it, and the decryption happens automatically after the like deadline of the auction. So there's just a single interaction, and in most of the other implementation in like the space, you need some kind of deposit. So if you don't reveal it, you should be slashed. But like in this case, you don't need any like, I don't know, deposit because other people are going to decrypt it anyway. And yeah, like one, I don't know, I think example is like NFT marketplaces and seal bid auctions for NFT marketplaces. The good thing is that you cannot really hype the value of the NFT by asking your friend to submit a bid for like 1,000 ETHs for your, I don't know, ape, and people will bid with something closer to the real value. And yeah, this was the main ideas that we've explored. But using the same infrastructure, exactly the same idea of like encrypting messages and decrypting them after the time deadline, or like after meeting a couple of conditions, we can get really creative and make other applications. The first idea is like randomness generation, like as an Oracle service. The idea is that the private key, the single private key that we are generating with IB, it can be effectively the source of randomness, right? So, and the good thing is that like even the last person who is sending their private key share they cannot wait and like for the last second and send their private key shares to affect the final randomness like results, because there's the private key. Once the threshold of them like send the private key, it's going to be the same private key. Even like it doesn't matter if you are the last person and the other guy is the last person. So this is quite nice. It can be used for gaming, and since the crypto is a big casino, so gambling is big part of it, and you can use like randomness for all of the gaming and like, I don't know, other gambling application, and it's also very important for some kind of fairness applications. There is also some more serious applications like private intents and like limit orders. The idea is that you can encrypt your transaction and say that the decryption should only happen when some conditions on the market is like are going to be met. For example, we can say that when ETH like meets 5,000 USDC, like decrypt my transaction. So this is very important for like DEXs, decentralized exchanges, and a couple of other DeFi players that we can enable. The difference here is that the ID that I was talking about in IB, here is not the time. You are not encrypting for like block 100 for decryption. You are encrypting for a price. And this is the idea. And the last idea, I know you're overwhelmed with all of these ideas, but the last idea is like censorship resistant rollup sequencing. So there is like a really big hype about shared sequencing right now. And the idea is that like single sequencer can sequence all of the rollup transactions for, I don't know, for example, like Arbitrum, Optimism, and all of the rollup providers. There is a like really good explanation for the reason of that. Like, for example, one of that is that we can have atomic cross-chain transactions. And for this idea, for like shared sequencers and like sequencers in general, they are good because they are decentralized. Nobody can censor your transaction based on like your identity, your address. If someone, like some some sequencer tries to censor you, other people can include your rollup transaction, but they are still not fully censorship resistant because they can still like censor you. They can have some kind of insider knowledge and censor all of the transactions based on the contents of transactions before sequencing. So the idea is that we can encrypt rollup transactions in the sequencing layer. And once the sequencing is done, like nobody has like any knowledge about the contents of rollups, they can execute it in the rollup side. So we will be like fully censorship resistant because we are decentralized, and also we have encrypted rollup transactions. And yeah, so to sum it up, like, so I talk about like the privacy is not just Zk rollups and like Zcash or Tornado Cash. It can enable a couple of applications, which is quite important for users. I know a lot of people doesn't actually care about, I don't know, privacy or like their data, but the key point here is in crypto, there is a special space that privacy actually means more money for you. It means like better applications. It means like better value for users. So this is a like very fantastic opportunity to build cryptographic libraries and build like better applications, even for the users who don't actually care about privacy. And yeah, it doesn't necessarily mean like you are going to be arrested to work on privacy. It's not like Tornado Cash necessarily, which is also like important, but like it's a safe area to work on privacy. And yeah, lastly, we are happy that we are building production-ready cryptographic libraries like threshold, identity-based encryption, and enable this kind of applications. Yeah, that's all. And please follow us on Twitter. We love talking to you guys more about these ideas. We love feedback, criticism, and we are also hiring. So yeah, thank you.